Day 285 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 322, coin change. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand, y'all. But before we get started, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now let's see what the question says. Question says you are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. You may assume that you have an infinite number of each kind of coin. All right, y'all. Sounds simple enough, but let's go ahead and look at these examples just so we can make sure we completely understand what it is that they want us to do, right? So in example 1, we have the input coins equals an array of integers 1, 2, and 5. The amount is 5 and the output is 3. Explanation says 11 equals 5 plus 5 plus 1. So once again, what we want to do is we want to find the fewest number of coins that we need to make up the amount, right? So in this case, the amount is 11, and we want to find the fewest number of coins right here that we can use to reach 11, right? So there are plenty of different ways we can use these integers to reach 11. We could do 2 plus 2 plus 2 plus 2 plus 2 plus 1, and that give us 11. We could do 1 plus 1 11 times, that'll give us 11. But remember, we want to find the fewest we want to find the fewest amount of coins that we need to make up this amount. And in this case, 5 plus 5 plus 1 is the fewest amount, right? Because that's only 3 coins. We only use 2 5 coins and 1 1 coin, right? Because it says right here, we may assume we have an infinite number of each kind of coin. So in this case, we want to use 5 twice and 1 once, and that's going to give us the fewest number of coins to reach 11. Whereas if we did 2 plus 2 plus 2 plus 2 plus 2 plus 1, we need 6 coins. Or in this case, or if we did a 1 plus 1 11 times, that's 11 coins. Well, in this case, we only use 3 coins. We use 2 5s and a 1, so that's why output is 3. And we want to remember, we're returning the number of coins, not how many coins we need. Like, we're not returning 5, 5, and 1. We're returning 3, the number of coins we need. We're not returning the actual coins themselves. So let's look at example 2, where they might try to throw a trick our way where it's impossible to reach that amount, right? So in example 2, we have the input coins equals an array of integers, and the integer is 2, and this time the amount is 3. The output is -1 because it is impossible for us to reach this amount of 3 with the coins that they're giving us. They've given us 1 coin or 2, so we could get to, if the amount was 4, we could get to that. If the amount was any multiple of 2, we could get to that. But since the amount is 3 and there's no way to get to 3 without going over or under, no way to get exactly to 3, we return a -1, right? It says right here, if that amount of money cannot be made up by any combination of the coins, return -1. And example 2 is an example of that, where no matter what combination we use, we won't be able to reach the amount. So let's go ahead and look at example 3, where it's a little different, because this time we're not returning -1, we're returning 0, but the amount is 0, right? So in example 3, we have the input coins equals 1, the amount is 0, right? So if the amount is 0, we need 0 coins. It's that simple, right? We don't have to use any of the coins. Whereas even though we cannot use any combination of this to reach 0, the combination is we just don't use any coins, right? We just don't need any coins, so the output stays 0. So now that we understand the question, let's get into the fun part, actual code, y'all. Code's not that difficult at all, so let's get started. Now, the first thing we need to do is we need to create an array to store the minimum number of coins needed for each amount, right? So in order to do that, we're just going to say var result. then we're going to set that equal to an array of integers. Excuse me. So open up the square brackets and put int inside. Then come outside of that, we're going to open up the parentheses and we're going to say repeating colon amount plus 1. Come outside the 1. Then we'll say comma and we're going to say count colon amount plus 1 again. Excuse me, that should be amount plus 1. And that's going to initialize all of the values of amount plus 1, right? So now we not done yet. We're just going to start. Now we need a base case, right? So just in case 0 coins are needed to make an amount 0. So we'll say result square bracket 0. We'll just set that equal to 0 just like that. Boom. Then we need to iterate through all of the amounts from 1 to amount. So in order to do that, we're going to say for I in 1 dot dot up to dot dot less than sign amount plus 1. And that's going to allow us to iterate through all of the elements from 1 to amount plus 1. Now we need to try every coin in the coins array. So in order to do that, we're going to say for C in coins. Boom. Now, if the current coin is less than or equal to the amount, it can contribute to the solution. So we're going to say if C is less than or equal to I, we're going to open up the brackets and we need to update the result with the minimum coins required. Either keep the existing value or we're going to use 1 plus result I minus C, which means we add 1 coin of C. So we're either going to keep the existing value or we're going to add 1 coin of C. So in order to do that, we're going to say result square bracket I, boom, then we're going to say equals min. So it's either going to be, we want to find the minimum number of coins, right? Remember, so we're going to say result square bracket I, come outside that, comma, or result square bracket I minus C, come outside the square bracket, still inside the parentheses, and we're going to say plus 1. Now, if the result is still greater than the amount, then we can return -1 because that means we didn't find a valid combination. So we could just come right here and we'll say we're going to return result square bracket amount, come outside the square bracket, is greater than amount. So if that's true, then we're going to say question mark. So if that's true, we're going to return -1. If that's not, then we could just return result square bracket amount. And that should be all she wrote, y'all. See, that code wasn't that difficult at all. Let's go ahead and run it. Make sure it runs properly, though. Because what good is code that doesn't run properly? All right, it's accepted. So let's go ahead and submit it. Make sure it stays accepted. Let's see. Okay, 12 milliseconds beats 60.19% of users with Swift. Not too bad, but we are just focused on being able to solve the problem that is presented to us, y'all. We're not too worried about the time complexity right now. We'll get more involved in better understanding of time complexities as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem. We want to be able to understand the problem, and we want to be able to solve the problem. And I feel like this was a good, simple, easy to understand solution for that, where everybody could learn from it and understand it and take the knowledge that they learn from this and apply it to further LeetCode problems. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.